So good morning, everyone. Welcome to another session of the GSE UK virtual conference for 2021. Today's session is session 7BG, presented by the esteemed Steve Warren from IBM, and he will be talking about introducing REST-enabled BCPI, a whole new way of controlling your Z hardware. As always, any questions, please raise them in the chat box, and then Steve will answer them at the end of the presentation. Steve, go get them.
Thank you, Ree. Thank you, Joe. And welcome to the last day of the GSE. And so hopefully you guys have had a great chance of getting all kinds of great information about the Z platform. This is a great conference to learn all about the new enhancements and new features and whatnot related to Z. And so it's always a privilege to talk to the GSA UK audience. And hopefully next year, knock on wood, that we might be able to have an event in person and to be able to have some good talking face to face. But in the meantime, let me just tell you a little about myself. If you haven't attended one of my sessions that I've given in the last 2 weeks at the GSE UK, my name is Steve Warren. I work in the IBM Poughkeepsie facility across the pond in the US, in New York. And there I work as a technology architect, helping clients adopt the latest technologies on Z. But in my prior life, prior to that job, I was the founding architect and principal SME for the BCPii component of ZOS. And so I'm coming to you today to talk about a whole new way of interacting with BCPii, and it's using a REST model to accomplish that. And so you're going to see some very cool technology here. I'm really excited about it, and I hope you will be too as we dive into the topic of REST-enabled BCPii. All right, like Rui said, please ask questions. I'm here for you. I'm not here to hear myself talk. I can do that, without being on the Zoom conference here. So please, if you have any questions, there is no dumb question. Just ask away, and I'll do my best. If you afterwards, after you've digested some of this material, if you have additional questions to ask, here's my email address, and always feel free to reach out to me. I'm here for you. Okay. So with that, let's dive in. So we're going to first give a really, really high-level view, overview of BCPii, just to level set you for maybe 2 minutes. And then, and then we're going to dive into many of the features related to BCPii in terms of the new REST interface. We'll give you an overview of the new service, including a sample of what the new things that BCPii can do. We'll dive into the actual API itself. How do I actually use it? Then we're going to talk about comparing the existing BCPii interfaces with the new ones. And then last but not least, we'll give 2 usage examples that hopefully will bring it all together. And at the very end, we'll say, how can I get my hands on this, and how do I get more information about this particular functionality? Okay. All right, so let's give a quick overview of BCPii. So BCPii, and this thing keeps fast advancing here. I don't know why it's doing that, but that's fine. I'll just have to backtrack it when it does that. BCPii is a programmatic way that allows authorized ZOS applications to be able to have control over the hardware on the Z hardware. And so I can have HMC-like control over the hardware using this particular set of APIs that we provide. And again, provided that you have lots of authority to be able to do these changes. So what can I do? I can monitor status changes. I can re-IPL, I can change capacity, I can query and update LPAR settings, I can set activation profiles. There's all kinds of functionality that BCPii provides, and it's all programmatic. It results in less error-prone hardware manipulations and functionality. So I can create a BCPii application or script that is basically going to perform a particular hardware action, and it's going to be done in a systematic way rather than having someone log on and doing it interactively. It's going to be done much faster with BCPii. And so this is kind of what BCPii is. It stands for Base Control Program Internal Interface. And again, it allows these applications to have these HMC-like control over the systems of all the systems in the process control network. It applies to both CPCs, it applies to images, it applies to capacity records and activation profiles. Pretty much a lot of the stuff that you can control on the HMC, you can control programmatically. And what's great about BCPii, and one of the really things that differentiates this from, let's say, the HMC Web Services APIs, is that unlike the HMC Web Services APIs, this does not use any external network. It goes through the very lower levels of the operating system and actually issues a machine instruction to the local support element to actually receive control directly through the low levels of the operating system. Therefore, you don't need to have an IP network. You don't have to open your HMC to IP. You don't have to, there's not, from a security perspective, a lot of clients are very comfortable with this. You don't need to worry about the availability of IP. The underlying hardware, if you can't communicate to the local SE, there's a big problem going on with your system that's much bigger than probably the BCPii operation that you're trying to perform. And there's a ZOS address space, of course, that manages BCPii. So again, from my ZOS application, I can issue BCPii API calls that will drill down through the lower levels of the hardware and communicate directly with your local SE. And if you need to communicate with another CPC in the HMC network, the SE will just use the HMC to route that request over to the other system using an internal HMC network that's established. Okay, so now there's a lot of people that use BCPii today. So whether it's XCF using system status detect to be able to detect when they miss a heartbeat from one system, what should they do? And so with system status detect, it gives you the capability of, they use BCPii under the covers to say, oh, I don't have a heartbeat from that other system in the sysplex. I'm going to reach out to BCPii. Is that system dead over there? If it is, it can partition it out of the sysplex immediately, freeing up potentially sysplex-wide resources that particular system may be consuming, and allowing the other systems in the sysplex to partition that guy out of the sysplex, which will hopefully avoid sympathy sickness from those other systems. And so, for example, XCF uses it. Capacity Provisioning Manager uses it. That they use it to actually be able to dynamically add and remove temporary capacity on your system through a set of policy controls that allow that tell CPM when they can add and remove that. Again, using BCPii. HDD uses BCPii for some functionality. You have several other components of the operating system that actually use BCPii. Then we also have vendor applications, and there's a lot of control center system management applications that use this. I'm thinking of a lot of the big vendors have a hardware automation frameworks that under the covers use BCPii, and as well as many system management applications that help you, for example, reduce the cost of your systems by changing the defined capacity on different systems based on specified criteria. The bottom line is that there are many applications that use BCPii. And of course, there's many in-house applications. You have, in your company, may have a BCPii application. There's tons of them out there. Lots of companies have coded to the interface directly because they see the value of being able to programmatically in a more automated fashion control some of the hardware operations that go on your system. Okay, so now that we've level set a little bit about BCPii, let's talk a little bit about this new REST API service. And so what is it? So this BCPii REST service has been created that allows you to program your application, and instead of using the traditional BCPii REST APIs, you can use a new flavor that looks like a REST invocation. Okay, so what you're going to be able to do is from the same languages that you can support, that the BCPii supports today, and that's C, that's Rex, and that's assembler. Through those three languages, you are able to programmatically control the hardware as you did before, but you're going to be able to use a REST-like interface. And though that REST-like interface is defined in the Z Hardware Management Console Web Services API. So we're using the same basic interface that the HMC Web Services API uses. That's another way today of people being able to programmatically use to be able to invoke a REST service to get information about the hardware and control the hardware. But the advantage of this methodology is that it does not use the TCP/IP network through communications. It uses that same pipeline as it uses today to be able to talk directly to the local SE to be able to affect those hardware changes. So you're going to, throughout the rest of this presentation, you're going to hear about this being called BCPii version 2. Let me make sure I clarify what that means. Version 2 does not mean that we're doing away with the old APIs. Those old APIs will continue to be supported, and they will continue to run as they do today. What we're talking about here is the new HWI REST interface, and this HWI REST interface, sometimes we just call it as version 2, so it uses less words. But regardless, both the traditional as well as the new interface will be supported. So what do I get using this thing? I'm not going to change my program just for the sake of changing my program. I need to get some benefits from this. And so we're going to talk about those. And one of them is you automatically, if you use the HWI REST interface, you have access to a whole new set of attributes that were not available with the traditional BCPii REST, non-REST API interface. So all the HWI APIs that you might have invoked before for BCPii to be able to get to various hardware attributes, there were a lot of attributes that were not accessible through BCPii. There's going to be a lot more that are available now with REST. So that's one reason to consider using the HWI REST interface. Another one is now there's a single documentation reference for attributes. So what is going to happen with this particular service is now BCPii documentation is not going to actually be documenting individual attributes anymore about the hardware. So if we're talking about total defined storage for a particular CPC, that's a new attribute. You're not going to find how to invoke it in the BCPii documentation. You're going to actually go to the HMC Web Services API publication to be able to find out the interface of how you do that. And so again, there's a single documentation reference for attributes. BCPii is leveraging the HMC Web Services API interface. And so when new attributes, when new hardware comes out, before with BCPii, there might have been a time lag when ZOS BCPii actually supports those new attributes on the new hardware. With this infrastructure, we now have the ability to leverage those new hardware constructs without any changes to ZOS BCPii. So what's going to happen is, most likely, you're going to be able to have those new attributes on the new hardware available right away or much faster than they would have been before, when there was this time lag where the hardware changed and has a bunch of new things that you could modify or query, but the ZOS BCPii had to also make changes to their code. Now it's going to be when that hardware is available, that these new attributes will be available as well. And now there's also a REST-like interface. So this interface is more intuitive to folks that are used to doing REST. You don't have to learn a whole new methodology of how you program BCPii. You're going to be able to use the same interfaces that you're used to using in many other applications, because you're going to be using a REST-like interface. There's going to be a URI that you specify. There's going to be query params, a request body, and a response body. The data is going to be coming back in JSON format and much more. So the bottom line here is that you're going to have additional flexibility to control that. I'm just trying to see if there's a way I can stop this thing from moving forward, but I guess not. So you just have to bear with me. This is the first presentation. I've given 8 presentations at the GSE UK. This is the first one that keeps auto advancing without me touching something. So my apologies for that. So we're going to compare and contrast between version 1 and version 2 in just a moment, but suffice it to say that this interface, it will be fairly intuitive to folks that are used to REST, and to jump from version 1 to use the traditional BCPii services to the new HWI REST service. You're going to find that it's pretty easy. In many cases, you have to invoke less BCPii APIs to get the information that you want. And one of the other big benefits of this is an easier command interface. You're going to see that HWI command today, to be able to issue commands, these powerful constructs that allow you to IPL a system through the load operation, or to be able to issue an operating system command on any operating system in the Z that runs on Z, or a whole slew of different commands. Commands, because of their asynchronous nature, and because that we use an ENF exit to actually give you the response, this involves a lot of programming, and it's very difficult programming when you're talking about REX, because REX doesn't deal well with ENF exits, and so you have to have a non-REX program, and it just gets to be a mess. With this interface, I can do everything through REST, and I'm able to get my response without having to deal with an ENF exit. I also am running TSO REX, or in an ISV REX provided environment. I'm able to invoke this new command interface. And so there's a lot of benefits for how to invoke commands, and that I can do it in a much easier fashion. So there's lots of benefits. We're going to go through all of these, and this is just kind of a high level overview of some of the enhancements that are possible with this new REST-like service. Okay, so let's talk about some of the attributes that I get right out of the box. When I switch to HWI REST, I now have lots of attributes that I can now access that I couldn't with version 1, or the traditional set of APIs. So I can find out the enablement and hash values of many different functionalities on the hardware. I can find out these additional interfaces information that in dealing with the LAN and with capacity on demand. When I'm dealing with storage, this is a big one. We've had lots of clients asking, why can't I view a lot of the storage that's installed on a particular CPC? So all this storage, these storage attributes are now available on the system. This satisfies many requests for enhancements by our clients to be able to display the storage available on the system. BCPii can be used amongst many other things as an inventory control, and to be able to pull reports about what I have installed across my Z hardware on my system. And so with many folks want to be able to gather all this information, and BCPii didn't provide some of these constructs. So now you're able to get all these things, whether it's VFM or it's traditional storage on the system. I'm able to see what's installed. I'm also be able to get a lot of power saving settings that I was not able to get out of the box. So this is very cool functionality. I'm able to see that. I'm able to get a lot of environmental information. We had RFEs for this, that they want to be able to monitor environmentals of their Z hardware through BCPii. And this actually satisfies that RFE as well. And so now you're able to find out that information. You're also, from an LPAR perspective, being able to find more detailed information about processors and their assignments to a particular LPAR. That information was not available with BCPI version 1 APIs, as well as detailed storage allocated for a particular LPAR. So that's really cool. And then remember, BCPI can control all Z hardware. So when we're talking about all Z hardware, you can even issue commands against other LPARs that are not on ZOS. So like, for example, NVMe load and dump are supported. So these are constructs that are available for Linux to be using solid state devices to actually load or dump. And I'm able to actually now use NVMe load and NVMe dump to actually IPL a Linux LPAR through ZOS BCPii. So again, that's really, really cool stuff. So again, I'm also have the ability to get detailed resource allocations for LPARs on a single CPC with one directive. So on one call, I can get a lot of the resource allocations for all the LPARs and get all the information back in a consolidated format. So these are just some of the new things that you can get. There's a lot more that you can get using HWI REST today. Okay, so that's one statement we have about HWI REST is some of the new functionality that you can get. But let's talk about how we actually use this particular REST API. Okay, so first of all, let's make a comparison of the two different services. We have the traditional ZOS APIs, which are listed here before, and we have the single new API called HWI REST. So unlike all these other APIs, you can just use HWI REST and different flavors of it to accomplish all the things that you could do with version 1, with a couple of exceptions. And you can just use HWI REST. So this is a standalone service. It does not require a prior invocation of any of the V1 services. So I can just use an application that just uses HWI REST, and I don't have to use anything else. So what I'm saying with that is that I don't have to actually invoke a V1 service prior to issuing HWI REST. I can just use HWI REST standalone, okay? What this means is the concept of a BCPI connect token has gone away with HWI REST. So if I'm using the HWI REST interface, I no longer need to use this thing where I connect to a particular resource like a CPC, an LPAR, a capacity record, an activation profile, a user-defined image group, for example. I don't need to connect to any of those things. I can just invoke a REST API immediately to start leveraging that particular resource, okay? So you're gonna see that the concept of a connect token has gone away. So again, with the new REST-like API interface, HWI REST, there's a single new API. The next thing we can talk about is a comparison is the input-output format. In version 1, we had the idea of all the data is coming back in IBM EBCDIC 1047 code page as plain text. In a couple cases, a couple of the attributes would return an XML data format, but most of the time it's just a plain text. And so here's an example where I actually issue a HWI command. I'm going to be specifying a couple of stem variables. I want to issue a particular command against a particular LPAR, and I want to do a display active list, a ZOS command here. And, you know, for example, I can get back, you know, a result. And, you know, in the example for my query, in doing HWI query, I get back a value, which is just plain text. So the idea here is that we're talking about plain text that we're sending to BCPI and plain text that we're receiving. In the new format, we're going to be specifying most of the time if things are in JSON format. Okay, so now you can use either IBM 1047 EBCDIC as the code page. Probably most folks like to use that because, of course, you are running on z/OS and you are running in an EBCDIC world. So probably that's what's going to make the most sense for you in that case. But also you have the option of specifying data to BCPii in IBM 10.4, in UTF-8 format. So it's your choice. So to do the same thing, to specify input on a request body, I can specify, again, in JSON format for the request body, and I'm going to be receiving the data in JSON format as well. And so the analogous left to right here, the same thing, how I specify in V1 versus V2, and how on the query, how I get a return value, it's going to be returned back in JSON format. Now, there is a JSON parser that comes by default in z/OS. It's called the z/OS Client Web Enablement Toolkit JSON parser. And that JSON parser, which is built into the base of z/OS, is highly recommended to use to parse your JSON. And so we actually provide in some samples that I'll show you at the very end of this presentation deck, references of some samples using that parser to be able to parse the data that comes back. All the data formats that are specified are provided in the data model inside of the HMC Web Services API. So in terms of how the data needs to be structured for input, how the data is going to be structured when it's returned, is all in the data model that's provided. So let's comparison how we get back error information. For version 1, when you invoked a service, there was a return code variable that would contain whether the request was successful or not. And then possibly it also provides some diag area information. And that was an area that you had to specify when you actually invoked the service, right? In the case of version 2, we're using a REST model. So we don't have a return code per se. We have HTTP status codes, right? And those HTTP status codes correspond to normal HTTP status values. So for example, a return code 0 in version 1 would be analogous to an HTTP status of a 200 range HTTP status value. 200 means good, right? It means okay. It means it was acceptable. And then there's also a reason code, and there's also additional diagnostic value in a response body. So these error response bodies will contain information. So in this example right here, we have some additional information that we provide directly in the response. And so the response body, if it's an error, will contain a lot of information that you need to be able to debug the problem. So it's business as usual when you're dealing with REST APIs. Generally, the response body that comes back on a traditional REST API for a failure will contain the error information you need to debug. Likewise, it'll be the same thing for BCPii. So now let's take a look at what this new REST API interface looks like. And we're showing you the Rex interface here today, but there's also a C and assembler interface that's provided too. And it's really a really simple service. Just like in version 1 with all the HWI services that are provided by BCPii, you specify address BCPii. That tells the Rex interface, direct this request to BCPii. Once BCPii has it, the next parameter is the actual name of the service, which is HWI REST, and then followed by the additional parameters. And there's 2 parameters. There is the request parm stem variable and the response parm stem variable. And this is, again, the Rex interface. There are C and assembler interfaces that are clearly documented in our pubs as well. So these stem variables are made up of multiple parts, of which you have to fill in some of the values, and some of the values you can just take default values. And so we're going to dive into how do I formulate a request with HWI REST. And it actually is not rocket science. It's really straightforward. I think you're going to like how simple this actually is to use. So here we are, and we have a request. So let's say we want to be able to get a particular attribute of a CPC. So in this case, let's say you want to find out what the MCLs that have been installed for a particular CPC. the microcode level that we're currently running with on a CPC. So you could get this attribute today with version 1. How would I do this in the new HWI REST format? Well, the way you do it is you would first go out to the HMC Web Services API publication, and that's what's listed here. And you can find out the pieces of information you're going to do. Well, according to this, if I want to get a particular attribute, I want to go and get CPC properties. And so the way I get CPC properties using the HWMC and HMC Web Services API is to actually do a GET request. So I'm going to specify HWI_REST_GET. That is a hard-coded value, a constant that is going to say, I want to do a GET for this particular request. The next thing is I'm going to specify the URI. So it says I need to specify a /API/CPC/a CPC ID. Now, this CPC ID had been obtained on a previous request I made to get a list of the CPCs, or I wanted to get the CPC ID for a particular CPC that I already know the name of. And so I took this value, the actual value of this entity, and that was returned on a prior request. So I fill that value in, and now I'm going to specify the particular attribute that I want. So I can specify a query parm here, and in REST nomenclature, a query parm is a parameter that I'm passing to that can actually basically tell the particular resource that I'm querying some additional parameter about that particular request. In this case, the particular property that I want to get is called ECMCL description. How do I know that that's what name to choose? I can go into the data model here, listed at the bottom of the screen right down here. It says data model. And in data model, it lists all of the attributes that could possibly be returned. And so I say, I want just that one attribute. Now, I could have omitted that. And if I omit the properties, I'm going to get all the properties. Probably not a great way of programming, because when you get all the properties, it has to go out and retrieve all of those things on the hardware. Okay. So as we know, the SE is a finite machine. It's a blade that's actually running inside of a particular CPC box, and it has limited capacity. And so if possible, we'd like to narrow down to the exact attributes that I want and not actually ask for all of them. But you have the option of not qualifying it with a query parm and getting all of the attributes back, right? The next thing we have to know is that we have this request parm target name. We'll talk about this a little bit more. This is a value that is we need to pass, that was passed on a previous request, and this is the net ID, or it actually represents the CPC name that is used in version 1 that we have to specify in version 2. You don't have to create this name. It will have been given to you on a prior service that I can pass in. Remember REST. If you know the concepts of REST, REST is what's referred to as a stateless operation, meaning that when I make a request to the CPC and it returns back a response, there is no state that is maintained on the server, which means that each request is completed and finished in of itself. However, that request, when it gives back a response that says, if I want to invoke it again, here's what I need to specify. And so this is a particular thing we're going to see that you need to specify for security purposes, and we'll talk about that in just a moment. There's also a request body. But in the case of a query of getting CPC properties, it doesn't accept a request body, so we don't have to fill that in. It's not applicable in this case. You can specify a client correlator if you want. This is just basically a name that will be returned on the response, and just a way of making sure that the request I'm making, the same response is coming back. And again, you can specify this. You can see that what that actually is. It's just a string that you can specify. You can also specify the encoding. By default, though, we're going to be specifying it's going to default to EBCDIC, the data that we're actually sending to the system, and the request timeout In other words, how long should this request be out there before the SE times out the request? So again, not necessary to specify. So you can see for this particular request, I only really need to specify 3 things: a get, a URI, and a target name. And all those values can be derived from the HMC Web Services API publication. How's the response look like? Well, again, I'm going to be going to get CPC properties and the data model. And the data model is going to say exactly how the data is going to look like, right? So in this case, I have an example, and I'm going to be getting back a bunch of information. It's going to give me back the response date and time. It's going to give back a location, and that's not necessarily filled in by all the requests. I'm going to have a request ID. Again, all these things are kind of standard. The key that we need to look at is HTTP status, and we want to make sure that that is a good value. And then the response body. In this case, I'm querying several different attributes, and so here's the value of the data. It's going to give back the data in JSON format. And again, the data model is going to tell you exactly how that data is going to be returned. Okay. Let's talk a little about security and BCPii version 2. So in BCPii version 1, of course, every API request that we make goes through a SAF check. So we need to verify that the person that the person that is executing this BCPii program, or the user ID of which it's running under, has the authority to actually query that piece of information or to issue that command, etc. So in version 1, we were able to derive that from the connect token. So we had this idea of connecting to a particular resource like the CPC name, a CPC, and then being able to query against that CPC using that connect token. So because we were able to maintain state and keep information about all these different connections, we were able to build the resource name or the profile name that we check against the facility class. With version 2, we don't have that connect token available. Remember, each one of these HWI REST invocations is stateless, which means that the request is considered complete at the end of that request. So how do I know what SAF resource I need to actually check against? And so what is returned in version 2, a target name is returned on a prior request that says, if you ever want to reference this particular entity, you're going to need to pass this target name into BCPii for it to validate the SAF authorizations. And so if you just take that SAF profile name and pass it in on a subsequent request, you're telling BCPii what request to validate. Now, some folks have said, okay, that's very cute, but what happens if I just change the SAF profile to something else that I know I have authority to? I can get away with, less security. No, what's going to happen is that if you don't specify the right profile name, the SE is actually validating that the target name that you specified matches what target name you should have specified. So the SE doesn't know what ZOS user IDs have authority to the request, but does know what target name that you specified on the request. And so if you specified a bad target name to the SE is going to say, I'm not allowing the request, regardless of what the user ID is. So the bottom line is you need to specify the right target name. So how that actually plays out. So in version 1, I didn't have to specify, of course, the SAF profile to check against. In version 2, I'm going to just take the target name that was specified on a prior request, and I'm going to just pass it in on subsequent requests for that particular object. So if I queried, if I queried, give me a list of all the CPCs, it's going to give me a list of all the CPCs and their corresponding target names. If I then want to query a particular attribute on that CPC, I'm going to use the target name associated with that CPC and pass that in as input. Again, to keep the REST stateless model intact and not to store information about that. here's a practical example of how we actually would go ahead and use this service and functionality. So I can actually do fill in just 3 values to be able to get a particular request for a particular CPC. So in this case, I want to get the total installed storage on a system. And so what I'm going to do is, from a prior invocation, I found out that the URI associated with a particular CPC is listed up here in the comments here. I already retrieved this value. Okay, and so I have this stored in a variable, and I also have this target name defined that was returned as well. So these 2 values were already returned to me. So what am I going to do? I'm actually going to say, okay, I want to get a particular value for a CPC, and so the HMC Web Services API publication says to do a get against a particular CPC resource, and then to specify any parameters that I want. So in this case, I'm going to do a get. I'm going to take that CPC URI that was returned to me and concatenate the query parm of what particular attribute I want to retrieve. I'm also saying cached accepted equals true. This is a way of fast pathing through the SE or the HMC to be able to get the most recently cached value for a particular attribute. This is going to be much faster for performance than if you don't say cached accepted equals true. It's what BCPii version 1 actually does to be able to, under the covers, to be able to get attributes for you very quickly. So again, saying cached accepted is true is going to be a good thing to specify. So, and then I'm just going to also pass that target name that I previously required, and that's it. So I just took values when I queried for a particular CPC, what is the URI and what is the target name for that CPC. And now I'm going to issue a get for that particular entity. So it's really that simple. And I just invoked the BCPii REST service specifying that request parm. Notice that when I'm checking the return codes, I'm actually looking at a different return codes. I'm looking at the status value, and I want to be greater than 199 and less than 300. Basically, anything in the 200 range means that it completed successfully. Okay, so let's compare version 1 and version 2 services. So in version 1, we have the idea of HWI list. You can still use HWI list in the in version 2.5, all your existing BCPii applications continue to work because we're not getting rid of those. We're just adding in addition the HWI REST service. So how would I get a list of CPCs in using the HWI REST API? Well, in this case, it's very easy. I can just do a get, and I can say /API/CPCs. When I do that, it returns back a JSON array, which contains all of the CPCs that I have authorization to. It's the exact same way. So before, it would give you just the names, M44 or T115. In this case, it gives back the names M44 and T115, but it also gives back some additional information. Some of this additional information, for example, the object URI and the target name, I'm going to be using on subsequent requests if I want to be able to get information about the M44 CPC, for example. Okay. So again, just a different format. Before, we just return you a couple things. In this case, it returns back an array, JSON array that contains the same information. So now remember, HWI REST is a connectionless architecture. So before, I would have to connect after going back to a prior slide, in version 1, I would list the CPCs, I would get back the names, I would then use that name to actually connect to a particular CPC that I wanted to connect to. In the new HWI REST format, I already on that first get API CPCs have the object URI. That in essence is really the connect token per se, because I'm going to be specifying that on all subsequent requests. But I don't actually have to have an interaction with BCPii to actually connect to that particular entity. By getting a list of the CPCs, I have the object URI. I can just directly query an attribute using that object URI. So now how do I actually query? Well, in the HWI query service, prior to HWI REST, I would specify a series of attributes in a STEM variable. And those attributes in the STEM variable, I would specify hard-coded names, and I would be able to then issue the HWI query service and then check the return code, right? In version 2, I've already had that URI for a particular CPC, and I already have that target name that was returned to me. If you go back to the prior slide, you notice that there's both an object URI and a target name. So now when I go back here, I'm just basically going to concatenate to that URI whatever attributes I want to query. Okay, so in this example, I had name, LUA, prof, the serial number, and an IP address associated with a particular CPC. And in this case, to do the same thing, I'm going to say properties equals name, last used activation profile, machine serial number, and network IPv4 primary IP address. Again, all of these values are defined inside of the HMC Web Services API data model. And again, I say cache accepted equals true for better performance. I then once I've set up those query params, I then am going to then specify the HTTP method, fill that in, it's a get. I then specify the URI with those query params, and I specify the target name that was passed on the prior invocation. Now I just issue the service. So it's actually very simple. I just skipped over the connect, and I went directly from listing all the CPCs, immediately querying an attribute. So less APIs in this example. Again, I'm checking to see if the status code is 200, then I know it's successful. For set, it's similar. So in HWI set, I'm going to specify one or more set of attributes that I want to set. In version 2, I'm going to use the post service as defined in the HMC Web Services API publication. And I'm then going to specify the particular in the request body, how I want to actually set those values. And so again, the data model and the documentation inside of the HMC Web Services publication will show you that in this case, I want to have an accepted status of operation in this case, and the processor running time type is system determined. So again, the same way of invoking in version 1 and version 2. Notice that I'm checking for an HTTP status of 204. 204 means successful and resource was modified. Okay. Now, for HWI event, you're going to still continue to use the traditional V1 service. The REST-enabled BCPii service does not support registering for unsolicited events that may occur on the CPC for a particular functionality. So in this case, I'm actually going to continue to use HWI event as I did before. You're still going to use the ENF68 exit to actually receive those notifications like you did in the past. Now, however, before, if I issued an HWI command in version 1 to be able to issue those very powerful controls, like I said before, I actually had to register for ENF exits to receive the command completion event in my ENF. And then basically, once I received that from my ENF, I then would wake up my program to be able to continue processing, because I wouldn't know deterministically if that command actually completed unless I looked at the ENF exit and the response that came back. In version HWI REST using version 2 services, you no longer need to do that particular functionality. I can basically invoke the service, and what's going to happen here is that instead of being able to have to use an ENF exit, I'm now going to be able to query if the command has completed through another API request that I can make here directly. So before I go on to show you how I look at to see if the command completes successfully, I just want to compare version 1 versus version 2. Notice that there are lots of options I can specify in the request body for a particular load operation, right? Notice that clear indicator and store status indicator here are two new values, for example, on the force command that we had RFEs against BCPii, requests for enhancements. BCPii did not support clear indicator and store status indicator values. With the new version 2, again, you get more functionality to be able to specify those additional options. So again, just another reason that HWI REST provides additional functionality. So now we've issued the commands, we've gotten the synchronous response, meaning that in both cases for version 1 and version 2 here, that BCPI has accepted the request and the request has been issued, but we don't know if the request is completed yet. So how do we do that? Well, in version 1, again, I had to have registered for an HWI event, and when that response came back, the ENF exit will give us push notification that in fact that we actually have gotten a command completion response. In version 2, we're going to do a pull methodology. So what we're going to do in this case is we're going to extract the job ID that returned back, was returned in the response, and we're going to then issue an HWI get against that job ID to see if the request has completed. And when that has completed, you will have the response directly inside of your application. So again, this is really cool. I don't need to invoke ENF exit. I don't need to have this ENF exit coded. I don't need to have another application that's going to be doing a wait on an ECB, for example, for that request to get posted. So just all goodness. Let's talk about SMF records very quickly. So BCPii generates SMF 106 records when there was successful updating of hardware resources. So when you actually made a change to the hardware, we wanted to have a log, a way of capturing who actually made the change, what application made the change, and what exactly did they change on the hardware, right? So for auditability purposes. So with version 2, we also support the same concept that we do we do cut subtype 1 and subtype 2 records for SMF 106. The difference is here that, of course, instead of normally it was just an HWI set and HWI set 2 for subtype 1, an HWI command or HWI command 2 for subtype 2 records. In this case, it's going to be HWI REST APIs that issue a post, put, or delete in their APIs. Okay, basically, and the same thing that does not contain the word operations in the URI. For subtype 2, it's again going to be an HWI REST API call that issues a post, put, and delete. That the URI does contain the word operations. So operations is akin to HWI command, and ones that don't have operations is akin to HWI set. Okay, and we've updated our extract example to show you the ICE tool that allows you to extract the SMF records. We've updated that to provide a simple non-programming example of extracting SMF 106 data for version 2. So let's just look at a couple of usage examples. So in this example, I want to know, for example, what is the initial general purpose processor processing wait? And is the initial general purpose processor processing wait capped? Let's just say I want to know those two particular values. And I already know that the CPC name is, this particular name, and that the image name is this particular name. How would I use version 1 versus version 2? Well, in version 1, I'd first connect to the CPC specifying that specific name. I would then connect to the image using that specific name that I have for the image name, specifying the CPC token of the CPC that I just connected to as input into being able to connect to the image. And once I've connected to the image on a particular CPC, I then can query the attributes and then disconnect those two things. How do I do the same thing with HWI REST? So with HWI REST, it's going to be pretty straightforward. I'm going to say, give me, please, the object URI and target name that I need to be able to get the attributes for this particular CPC. So what in this case I'm going to do, I'm going to say get API CPCs, and I'm going to qualify. I already know what the actual a CPC name is, so I'm just going to specify it directly here on the URI, on the query prompts. It's going to return back to me the object URI, and it's going to give me back the target name. So then I need to be able to query what image URI I need to be able to query the actual attributes. So in this case, I'm going to use the object URI that was returned on the first request. And in this case, using the data model and the information defined in the HMC Web Services API, I find out that I can narrow my search down and ask for a logical partition of a particular name and get back its URI and target name by specifying this particular URI. So again, I'm going to be specifying an object URI that has this particular entity, here, and I'm going to get back the object URI for the actual image on that CPC, and also the target name. I'm then going to specify those same values on a third HWI REST call to actually get the attributes for a particular image that I want. And again, all of these attributes are defined in the actual model for the particular request inside the HMC Web Services API book. And again, the model will also tell you how the values, the return value will be formatted. Okay, no need to disconnect anything. We never connected to anything in version 2. So that last step is not necessary. Again, just the different ways of comparing between the existing set of APIs and the new set of APIs. A little bit more intuitive for folks that are familiar with REST in particular. Again, here's a comparison of we already have a connect token in version 1 to establish, has already been established for an image. And in version 2, the image URI and the corresponding target name have already been obtained. We want to reactivate an image. How would we reactivate an image? Well, in version 1, that's a command. And so for commands, I actually need to register with HWI event for command responses. I then had to code an ENF exit that would be able to get back that notification. And I would then issue the HWI command activate command to actually be able to issue that command. And then the ENF68 would be able to, would receive the push notification when that actually completed. It probably would also, that ENF exit would post an application that wasn't written in Rex that would be able to, that would be waiting on an ACB, and then you would know that the activate completed. In version 2, it's much simpler. No need to register for an event. I just am going to post with a particular URI that was returned to me in a prior invocation. I'm going to say concatenate that with /operations/activate as per the HMC Web Services API documentation. I'm just going to be passing through the target name that was specified that was associated with a particular image in a previous request. And what is returned is this job URI. It's this this format. This URI is passed back to me in the response. I'm going to then issue a get against that particular URI and specifying the target name again. And it's eventually going to return back that the status has completed. And it says 200. I have completed that particular request. So it's just a different way of looking at the data. Okay, so lots of cool functionality, a lot of attributes out of the box. When new hardware comes out, BCPii is automatically going to support that new hardware. You go look in the HMC Web Services API publication to get all the updates. TSO and ISV Rex environments also support commands now, which they didn't in the past. And there's also even another thing that's not even documented in here, which is that the modify AXR command, that command, which was before restricted from issuing system recs, BCPI calls within a system recs application, with additional service that you can get from IBM, you can now issue the modify AXR command to actually invoke HWI REST invocations. Okay, so another cool benefit that I can now use the command to actually invoke system recs commands. That system recs application can now contain BCPii requests, which before was restricted. How do I get my hands on this technology? Well, if I'm running on 2.5, I already have it. It's in part of the base. If I'm in 2.4 through continuous delivery, I'm able through this APAR to be able to get the right software. I do need to be at a particular firmware level, and notice that HWI REST applies to Z15 hardware only. So the firmware has been updated to support this new interface with BCPI on Z15. You cannot target Z14 with HWI REST services. And again, the firmware needs to be updated and the software. Okay, so again, you're going to need to make sure that all of the SEs that you want to target have this technology, and that the HMC that's associated with the local CPC has also this particular technology. Local CPC meaning where I'm actually issuing this HWI REST invocation from. The CPC that is standing up the LPAR that is actually invoking the HWI REST service has to have the updates as well. Okay. All right. Publications have been updated. So the callable services for high-level languages will tell you a little bit about the HWI REST service. But in terms of actually knowing what particular data model and what is the format of a particular HWI request URI and the data model of the data returned, you go look in the Hardware Management Console's Web Services API publication. There's been some updates also into these publications as well. And last but not least, GitHub provides several samples. If you go to github.com/IBM/ZOS-BCPii, you will have at your disposal several samples that will help you to start using this tool. So rather than writing everything from scratch, a sample is your best friend, and it's going to give you a framework of which you can then modify your applications. It also contains of how we invoke the ZOS JSON parser, so that you can parse the results in a very systematic way. So that's all we have right now. I went a couple minutes over. I apologize for that, but we really would appreciate your feedback in relation to this session. If you could just take a moment to fill that out, the GSE UK planners would be very grateful to get back feedback on this session. Again, the session is 7BG. And I guess I just ask, are there any questions? I know there's a lot of material that I covered in 1 hour, but I just wanted to make sure that I got through all of the material. Any questions for you guys? I know it's the last day of the conference and a lot of people are just burned out from, they have Zoom lag or I don't know what they have. They're just tired of being on these sessions. We appreciate you coming to this session, but you know, like I said before, my email address is on the very first page, and I would encourage you to leverage that. If you have any questions whatsoever, please send me an email. I'm here to help you and to help answer your questions. So please, you know, feel free to ask it. We've had a lot of clients that have started to use some of this new technology, and they're very excited about it because they know that when new hardware is introduced, that they're going to be able to leverage new hardware attributes right away, and they're able to do things in their program much easier with this new interface. Most of the new updates provided by BCPii will be done to just this new interface and not to the legacy interfaces that were provided.
Excellent. Thank you very much, Steve. I don't see any questions being entered in the chat box. So in any case, again, thank you. Excellent presentation. For everyone else, our next session will be at 2 p.m. UK time. And the subject will be, how can I use open source languages to modernize business critical applications on ZOS? So until then, guys, have a nice one.
See you guys. Take it easy.
Cheers.
Have a good one.
Bye-bye.